Hi, and welcome to another edition of Core 3D Modeling taught by Mariana Williams for the University of Delaware. Today I just want to talk a little bit about some standard materials as well as a scanline renderer versus an art renderer in 3ds Max 2018. In my case, I'm going to be using a scanline renderer and the mental ray renderer in 3ds Max 2016 simply because we're still having some licensing issues with the educational license, so I would just be sure to point that out as we go through the tutorial. But I still think this will be really helpful as far as determining how we're working with fairly straightforward standard materials and lighting within a scanline render, and how we're working with physically based lighting in a renderer such as the art renderer or mental ray or Arnold. So let's go ahead and get into it. I've set up a 4-point viewport here using Alt-W. If you're not there, it'll just reset your viewports. I have a perspective window here. I don't yet have a camera in my scene. Perspective here in wireframe mode so that I can sort of monitor what's going on. I have a top view and a left view. And this is some sort of scenario that I'm comfortable working with. Sometimes I'll switch back to that full-on using Alt-W, or I'll go back to that default workspace and I'll max that out. You can also switch in 2018 your viewports in this lower left-hand corner. So just a little bit of review on that. Today I've created an L extension across a plane and I've set it up in a perspective mode. So just quickly, I want to make sure that what I see within my browser, or not browser, my screen here, this window, is what's going to appear in my render. So I'm just going to go in, clicking on perspective, just to be safe, I've done show safe frames. And when I do that, I see, oh my gosh, my plane is a little bit, this isn't quite what I was thinking. It's maybe like not the aspect ratio that I want, aspect ratio being height by width, that proportion. So I'm just going to go into my render settings and I'm going to say, okay, well, my output size, a little bit of review here going into HDTV, but I also know that that 1.7, that's the image aspect ratio I want for my rendering for the purposes of this demo. But I realized that when I start applying materials and then try to render, this resolution is going to cause me too much time before I'm ready for my final rendering. So I'm actually going to lower that as I work through this model, as I test things out, and that's just going to speed up my workflow so I'm not waiting too long on a render time before I'm really ready. It's going to allow me to work in a draft mode, and then when I find something that I'm happy with, change those settings again and render a full draft. So a fully finished product. So I'm just going to switch this down to maybe 720 for now. And you see that my height has automatically adjusted because my aspect ratio is locked. It's great. It's exactly what I want. And I'm just going to close out of this in a minute. But you see that I'm working in a scanline renderer. And just while we're in it, maybe I can render this perspective window. Find something that we're happy with somewhat. If I hit render, it's rendering really, really flat, maybe because I'm in consistent colors. Let's try it in the shaded mode. Just hitting render again, it's still super flat. So let me talk a little bit about why it's so flat and how we can use this to compare a standard material and a scanline render, which is really just registering all of the pixels across the screen, versus something that's physically based. It's based more on the lighting within actual space as we experience it. So in the real world, the appearance of a surface depends on how it reflects light. And that's going to be a physically based render. That's going to be the art renderer, the mental ray renderer, the Arnold renderer, which is new for 3ds Max 2018. But in computer graphics rendering, 3D models exist in this Cartesian X, Y, and Z world space. And we see that in our top view perspective. When we hit the W, key by selecting an object. Get out of this really quickly. Let's say, and I hit W. You see this X, Y, and Z. This gizmo represents how we control our objects within that Cartesian space. And the images themselves are made up of illuminated dots called pixels. It's just pretty basic. We're talking about, each little dot on the screen is a pixel of light. So the job of the computer is to determine the color for each pixel based on the model information, right here, the colors, and the viewport of the camera, which we don't have a camera now, but this perspective view is acting as our camera. So in lighting, in a scanline renderer, we're looking for a function of the physical material properties that we've set up. Right here, these are just basically stock colors, and the light that illuminates it. And in the case of 3ds Max, because we haven't created any lights, 3ds Max is using an algorithm to calculate what the light might appear to be. So it's actually completely artificial. Another thing about a scanline render, if I just click my render window one more time, it's actually rendering within a line from top to bottom. So it's rendering each pixel as though we're standing in front of the camera pointing a light beam directly onto our object, and then it's reflecting directly back at us. So there's no color mixing between any of the planes. If I had another box, let's say, if I come into my standard primitives and I create a box and we're to render, there's no reflection from this box onto the L extension. So there's no color mixing, there's no soft shadows. We are simply seeing the one-to-one color that the computer recognizes off of that flat material. So this is pretty much how computer graphics went up until around the 80s. And a lot of computer graphics engineers and optics engineers began to look at thermal technologies, and so that we could find another way to illuminate this space and another way to map the light and how it performs within a computer screen. So this is sort of what we think of as our photometric lights. And a photometric light you can think of as like a real world light. So the incandescent bulb that you might screw into your bedside table, maybe a fluorescent light overhead, any sort of street light, that sort of thing, any sort of light that we can quantify and work with in the real world that, can work with lumens and candelas. That's a photometric light. And these lights are used by the physically based lighting renderers. So you don't really have to be an expert in the history or the logic behind this, but I think understanding a little bit about how these programs are built allows us to create more effective models and use the tools a little bit more effectively because we know why things are working the way they are. So this rendering technology is really called radiosity in 3ds Max. So when we're working with radiosity, we're primarily talking about something called global illumination. It sounds like a little bit crazy, radiosity, global illumination, but you can simply just think of radiosity as a rendering technology that realistically simulates the way in which light interacts with an environment. So it's a simulation of how we experience light in the real world. So when we're talking about that global illumination that I'm talking about, let's talk about how light is transferred between surfaces. So between these two objects, that's the global illumination. A local illumination is how light is reflected off of an individual surface. So you can think of it global, we're thinking about everything in the context of our composition. Local, only the light that's reflecting off of this. So it's pretty useful because after that, it allows us to work with, if we're using an art renderer or an Arnold renderer or a mental ray, we can work with effects like indirect light, soft shadows, color bleeding between surfaces, and we can suggest a realism that's really not attainable with scanline. So that's really helpful. So this demo today, we're going to work a little bit with scanline and working with sort of a ray tracing with scanline to see how light's transferred that way, but we're primarily going to be working with a physically based lighting renderer. I'm going to be using mental ray because that's what I have on my computer, but for the purposes of the class, starting out, why don't we start with the art renderer, because the art renderer is going to give you a very simple interface at first, but give you really great results. So later in the class, we'll probably be working with Arnold or mental ray. Most likely Arnold, because that's what's installed on the computers. But they're very, very similar, and they can do similar things. They're all fantastic options. They're just used for different purposes. The art renderer, for example, is not great with transparencies because it's mainly for architects and industrial designers and other types of designers who typically just need a quick, beautiful render of a prototype. So not great for the same sort of animation things that maybe an Arnold render or a mental ray render might be good for. Okay, so one last thing about light and how light works, and we'll get over the science lesson. As you see, when we have an object that's pretty smooth, kind of like this box, that's going to be, we want to really consider the surfaces and the materials as far as how rough or smooth they are, because that's going to affect how light travels. So if light is reflecting off a very smooth surface or a specular surface, think specular like specs, like your eyeglasses, or specular like, a mirror, that sort of thing, it's going to reflect that light primarily in one direction. It's going to create these little hot spots where you see like the actual spotlight coming off of it. If it's a diffuse surface, say this ground is made of concrete and it's pretty rough and it's got a lot of noise in it or a lot of different, changes in the texture of that object. When a light beam, a photon, just a particle of light, hits that surface and reflects off of it, it's going to reflect in all different directions. And that's a diffuse reflection. So I always think of diffusion or a splitting apart of the light to help me remember. So I think spec for eyeglasses, my lenses are pretty shiny when I wear mine, or diffusion, diffuse, spreading apart, just helps you when you're working with some of the tools within lighting here in 3ds, or in some of those parameters within the material browser. That's going to help you remember which one you want. So I think that's pretty good. One last little bit about radiosity. I know we talked about it had its beginnings in CGI in the 1980s, and it was based in thermal engineering research from the 60s actually. So this is how we're starting to develop our physically based renderers. Rather than calculate the color for each pixel, like we discussed earlier in the demo, we're saying, okay, well, it's a 1-to-1 ratio, the computer's sort of determining what the material properties are and how much light is needed to illuminate that pixel. A radiosity rendering calculates the intensity for all of the surface in the environment, sort of like a global illumination, and it uses that collective data to create a more realistic rendering. Okay, excellent. So for all intents and purposes, we have no lights in our scene. So the computer's just thinking, all right, I've got a very, very basic rendering, and I'm going to use whatever computer stock data I have to create a lighting scenario for this render. In 3ds Max 2016 and in 2018, you can go into lights. It's been a little bit simplified in 2018, but we're going to go into lights, photometric. We're going to create a free light. And when I select free light, it says you are creating a photometric light. It is recommended that you use the logarithmic exposure control. Exposure control settings can be adjusted from the environment and effects dialog. You want to change it, and Honestly, anytime 3ds Max suggests something like this, it's probably a good idea to listen to them and just go for it. So I'm going to say, yeah, sounds great. So I'm going to hit yes. And now I'm going to create a light in my top view just by simply clicking and dragging. I'm going to hit W. This is why I use multiple viewports. Move it up in my front view till it's over my objects. And quickly, I'm just going to render one more time. And I'm still working as scanline, but I want to see what happens. And you see that the lighting is completely changed. And it's a little bit different in 2018. Sometimes when you put in a free light or something like this, you see that 3ds Max is no longer determining an arbitrary light. It's sort of now starting to think about, all right, well, where's this light, and how did the designer, artist, or animator, how are they, or you, placing things within the scene? So now you're the boss. 3ds is totally at your control for lighting. Sometimes you might do that and the screen will turn black when you render, and you'll be like, oh my gosh, what's happened? It might be that your light is hidden or underneath something or too far away. It's just little things to check for, but it probably means that it is working. If we wanted to get back into our environment and effects, our exposure control, to change those lighting settings, just like that pop-up dialog box introduced to us, we would actually go into rendering here, then exposure control, and you see that we have this environment and effects panel, and here is that logarithmic exposure control that we wanted. You can also do an automatic exposure control, preview that, see that rendering maybe a little bit better, but we want to do logarithmic right now because we're going to be adjusting this a little bit more. Okay, so it seems that our light's just a little bit too intense. So why don't we go in and try to fix this? Alright, so I have my free light selected. I'm just going to go into that Modify tab and look at this. So this is actually, a lot of these parameters have been simplified and actually been adjusted a good bit in 3ds Max 2018, and it makes your life a little bit easier, but for now we'll primarily work with the intensity of the light. So say it's right here, it's working in candelas and lumens. It's at 1500 right now. Why don't we render this at maybe 500? Get the light at 500, and we can just compare what changing that parameter does for us. Okay, so we're now working at excuse me, 500. So I'm just going to render, and you see that if I render the right viewport, it's changed that a little bit. So it's getting more close to the automatic exposure control. It's still quite bright, but you see that everything's still very flat and there's still no color mixing between things. That's because we're working in a scanline renderer. So I'm going to go ahead right now and I'm actually going to move over to my mental ray renderer. If you're working in 3ds Max 2018, perhaps you want to switch to the art renderer. Just change it right here, and I'm just going to hit render. You see that things are changing quite a bit, and I'm getting some reflection from the ground onto my box. There's a little bit more color mixing, a little bit more realism here. And within class, we went over quite a bit more about the light settings and this little free light here. And for all intents and purposes, we went into, you can change the shape of that point. So let's say a line, rectangle, and that's going to cast light differently. But for now, I'm working with the point light. We also went into some more advanced effects, depending on what renderer you're using, as well as, these ray trace shadows. It's going to be just fine. The target distance, how far that light is being cast, the near and far attenuation. And just to keep this demo under control, time-wise, I think if you have any questions about that, feel free to send me an email. We can look at your project one-on-one. No big deal. We'll just set up a good time to work with that. But I'm actually going to go into assigning some different materials to these objects so that we can compare a specular surface versus a diffuse surface. And yeah, just showing you how to maybe map some noise onto an object. And then I think we'll close this demo out for today. So to open up my material browser, I'm just going to hit the M key. And I've already created one material in this. If you're using the art renderer, you'll notice that you'll have the standard materials. You'll also have materials for the renderers, specifically to each renderer. So you'll have art rendered materials. I believe you'll have a series of maps. Maps are not materials. Maps are they're parameters which link into materials to give you more control over how they appear within your 3D space. And you want to be very careful to check within your render setup that you're using the same renderer that you use for your materials. So you don't want to be using an art material with an Arnold renderer, for example, because those may not be compatible with each other. I mean, they might be, but they may not be. And if they're not, then you're going to get an error message when you render, and it's probably going to render whatever it can't recognize as black. It's very similar to if you've ever worked in like Adobe InDesign or Adobe Illustrator and you don't have a certain typeface or font. It shows up as a default serif or sans serif. You know, that is a similar thing. You need to use the renderer that's compatible with your material and the materials that are compatible with your renderer. So just make sure those two are one-to-one, make sure they're the same. Okay? So I'm just going to be working with standard materials today in my example because I believe you also have standard materials with the art renderer. Couple quick things about the slate material editor. If you see a material and you've linked it to your object correctly, all of this stuff, but you still don't see it in your viewport, it may be because you need to have this button checked. It's the show shaded material in the viewport. If you have it unchecked, you see this is no longer, loses that little red flag across the top of this. So I'm just gonna, I like to click it just to be safe anyway, just so I know it's working. The only times I really unclick this is if I have a material that's a little bit too crazy and it's preventing me from seeing what's happening in my scene. So otherwise it seems to be fine. If I actually double click this material icon, I can see a larger preview of that. Can minimize the text and the parameters below that. Get it back by hitting that plus sign. I can also double click that icon again and get back to a smaller view. Let's just play around with that. If I have a ton of materials, for example, if I drag in, say I keep dragging materials into the viewport just arbitrarily, right? And I need to sort of organize these guys, I can actually hit this layout all vertical. And you see that all my materials now are laid out really nice and neat. I actually don't need all these materials, so I'm going to just select them, highlight them, and just hit the delete key. And we're just going to start from scratch. Okay? So I'm starting with a standard material, and I'm just going to select that name and drag it into the window. And I'm going to lay that out. See this layout all vertical. That also brings the material to the forefront. I'm just going to click on this. This is going to be my this is my first specular material. You can think specular, shiny. We're going to make this really shiny, okay? The blend is fine. This is great. This ambient and diffuse color, it's linked. You can, the ambient, the light that's being reflected around the surface of the object, I'm going to make this sort of a greenish color. And I don't know, this is a nice purple. Maybe we'll make it purple. Just hit alright. And self-illumination is if you want the object to emit light in its own right as a light source. Specular level, remember this. This is how shiny it is. I'm going to increase that a bit. And you note that the sine wave here is increasing. So as I'm maybe I put this up to 20, you notice that I've got quite a bit of light that's going to be reflected. And if I double click this icon here, perhaps I can increase the glossiness to 50. You see that this preview here has changed. I'm now seeing this sort of light beams reflecting off this. This seems to be a pretty shiny material. The soften amount, how soft that is. You see this sine wave is now peaking. So looks like we're getting a pretty shiny, very mirror-like surface. Maybe I'll change this down to like a cooler, blue or something. And let's say I'm really happy with this specular material, even though it's kind of a crappy blue color. Can't ever seem to get these right. And I'm just going to click this little orb here and drag this anywhere onto my material. And now if I render this scene, whoa, the wrong one. If I render from the right viewport, I'm now getting a much different lighting condition than I had before. Not too much different. Maybe we can change this L extension a bit to a diffuse material and maybe add a bump map to it so that we can see a little bit more how that light's interacting with each other. I also think I'd really need to change this light's a little bit intense, but we can get to that later. So I'm just going to drag in another standard material, double click it to select that. This is going to be my first diffuse material. And I'm going to make this guy, I am going to make it green. Why not? Super green, okay? I don't want it to be glossy at all, so I'm just going to bump that down to 0. And if I go into this maps channel here, you have the same one in 3ds Max 2018, and I select this bump map here. It says none. I'm just going to select that none, and I'm going to select, I have all of these guys I can work with. The dent map works pretty well. They all do different things, so I highly encourage you to play around with them, see what they do, make mistakes, find the limits of your tools so that you know how to work with them. But for today's demo, I'm just going to select this noise parameter. It's different from the noise that we animated before. It's simply creating some sort of relief on the surface, some noise that's only going to appear in the rendering. It's not actually going to appear in our viewport. So if I double click this, you see that once I've applied that noise, my surface is bumping, it's becoming dimpled. So let's actually play with, so if you see here, this noise map that I've just linked here has suddenly appeared right here into the bump channel. So we've got the bump map, bump channel, map here, which appears. If you decide you don't like that map, or you don't like that bumpiness, just click and drag it away. You see that preview changes. So I'm just going to drag that back in, hook it back in, plug it in to the bump channel. And I'm going to double click that map itself. And I get all of these little, I get the offset, the tiling, the angle. I've got regular noise, fractal noise, turbulence, and these are all giving me the size. This is the X, Y, and Z. This is how that map is tiled, or how it's displayed on your object. Work with that in a second if you need to. Let's say you have a hardwood floor and you need the grain of the wood to go in one direction, and you need that to be pretty prominent. So you add in a texture map into your material, let's say in the bump channel. Maybe your wood is, the long grain of that wood's going in the Y direction, so maybe you tile that and you make that Y long and you make this X and the Z a little bit shorter, just to accentuate that. those are very detailed considerations. For now, why don't we just work on the size of the noise, the amount of noise. So let's say if it's 25 now, if I make it 5, see it's gotten much smaller in my preview. Okay, and as well as the noise type. And we'll just start with this. Okay, so just to preview this and to sort of show you what I was talking about, I'm gonna drag it onto my L extension. You see that noise doesn't appear in my viewport, but when I actually render, the noise should appear if it's compatible. It seems that, let's see what we got. Just gonna move this a little bit closer. Okay. Maybe the noise is too small. So I'll try to bump that up to 25. This does work within the art renderer. I need to we'll check and see if it's how it's working in the mental ray renderer. So it seems that it's not working so great. I know it's working here. So why don't we troubleshoot that and see why not? Okay, so just to double check, we were having some trouble mapping our noise parameter into the bump channel. In 2018, this is not a problem. Don't worry about it. You can map noise into the bump channel, affect the scale, and adjust accordingly. But for now, we're going to replace noise the same way with a dent map. I see that our surface in our preview has changed. I'm also going to, just for kicks, I've got another map here, which is wood. I'm going to apply this into my diffuse or my color itself. You see that? So now giving me this crappy plywood. So it's shown up in my material viewport. Alright. And now if I actually hit render, you see I've got both a dent and this wood. Sort of, it's way bigger in scale. Let's see if we can go in here and go back to our material. And perhaps if we use a real world map scale, we might be able to change that preview. But for now, going into my map of my dent, and you just see the same way we would change this size of our map within the noise channel or anything that's put into our bump channel. I'm just going to work that down because you see this dent is quite big. I'm going to work that size down to 20, just press enter, just to show you what changing that scale of that one size parameter will do, whether for the dent map or the noise map that is applied to the bump channel. Just hit render. You see now that bump mapping, which doesn't appear in my viewport, has now actually become much smaller. So if I didn't want to see this wood grain preview in the viewport, I could select this object. I could select this first diffuse map and unclick show shaded material in the viewport. And if I do that, it's just going to go back to the standard ambient and diffuse color that I've set for this material. So if I unplug the map, you see, and I render, it renders with my bump or dent map still, but it loses the wood texture. If I plug this wood texture back into the diffuse channel and I hit render, that would come back. And if I wanted to make that wood texture a little bit smaller, I could change the parameters here and the scaling of it just like I do in the dent map. Maybe by saying the grain thickness is too big, what if I make it 1, for example, and I render that. It becomes much smaller. So I like to just change one thing at a time. That way I know what's going on and I know how to change that. And I know what my actions are doing as far as, how to change a model. So this is just an introduction to materials, adding in a photometric light, a little bit of background on types of rendering, and in further demos we're going to get more into how to adjust these parameters a little bit more, reflect that light off of two surfaces to create a better global illumination, and how to control those lights a little bit more. But just wanted to give you an introduction, and thank you for watching.